All right, so we're going to talk about exponential translations, and we touched on this just a little bit in class, but it's pretty important because a lot of our EOC stuff is on this. So make sure you have your date, okay? And we're going to look at this equation first. If we bring up our calculator and we put 4 to the x power, and then we want to hit zoom standard to graph it. We get this equation, okay? So this one, when you only have the b to the x power, that's called the basic, or some books or people will call it the parent equation. So that's basically where we start, okay? And then we can start doing things to this equation to make different things happen. So if I want it to go through, well, let's see if we look at it now. Right now, it goes through, we hit our trace. Right now, it's going to go through the 1 because over here, our A is 1, right? Because you don't see 1 there. Here, the y-intercept's 1. So if I want to change this to have a y-intercept of 3, I can take my parent equation and I change that to a 3 times 4 to the x power. So now, when I go to my calculator, and I just want to change this, I can go 3 times 4 to the x power, and now it should go through that's the first equation. I press the up arrow to hop up to the next equation. And now it's at 3. So I took my parent equation, I changed the y-intercept, okay? Or I can take my parent equation and I can make it translate. So if you remember, translations are a shift left or right, or it can be up or down, okay? So the equation doesn't change. The curve is the same curve. Remember, geometric sequences are exponential functions, so the common ratio stays the same. We're just moving it in different places around the screen. So one of the things that we have to know is, I'm going to go back to my parent equation here, y equals 4 to the x, and let's say I want to shift it. So if I want to shift it right or left, I need to add a number, add or subtract a number to the exponent. A number to the exponent. Okay, so I'll take my y equals 4 to the x power, and let's just say we put plus 4 there. So we go back here, and I'm going to do this, and that's my parent equation. I'm going to get rid of that 3. And if I want this, I need to make sure it's all in the parentheses, and I do plus 4. And then I hit graph. So you can see here's my parent equation, my 4 to the x, and then here's my translated equation, and you should be able to see it moved over 1, 2, 3, 4 units to the left, okay? So we can say here, when we add a number, it moves to the left. And then the opposite should be true if we subtract a number, okay? Let's move this up a little bit. So if we take my parent equation again, and we have y equals 4 to the x minus 2, what should happen? Let's see, we'll change this to minus 2, and I hit my graph, and this time here comes my parent, or my basic equation, and then my translated equation comes next, and you can see it moved over 1, 2 places. So you can just say when we subtract, it moves right. And we talked about this in class a little bit. Kind of does the opposite of what you think. You'd think minus would make it go to the negative direction, but it doesn't. And you'd think plus would make it go to the right, but it does the exact opposite, excuse me. Then we looked at a couple other types of problems. Go back to my basic equation. Now if I want to translate it up or down, it's a little bit easier because it actually follows the way you would think it. So let's say I want to move it up 6 units, okay? So this time it doesn't get put in the exponent, it just gets added to 6. So I'll go back here and we'll go down, and then I'm going to get rid of this by hitting delete. And then this time we're just going to add 6 to the equation, and you can see here's that, and then that went up. If you look, it went up 1, 2, 3, 4, 5, 6. If we do our trace, there's the 1, and then if I move up here, it went to 7, so it went up 6 units. So basically we can say here, when you add to the equation, it moves up. So then the opposite should be true too. So when we subtract to the equation, it moves down. My head might be in the way of that, huh? Sorry. It moves down, okay? So left and right is tricky. Left and right does the opposite of what you'd think. When you minus, it goes right, and when you add, it goes left. But when you're moving it up and down, it does what you think it would do. So let's look at this example here. We want to write this and look at what it's doing here, okay? So if my parent equation is x, and I did x minus 7, what would happen to the graph? Well, going back to our notes, why isn't that moving? There we go. This was minus 7. This one should go, it should translate down 7 units. Okay? And if we look at this one, here's my basic equation. My new equation subtracted 8. So it was subtracting 8 to the whole thing, so then this should go down 8 units, right? Here, we took our parent equation, our basic equation, we added 1, so the whole graph should shift up 1 unit. Okay, you do 5 and 6. So now let's look at these types of equations. You can see they're doing something to the exponent. So that tells me right away it's going to go left and right. So if I look at this very first one, my basic equation is 3 to the x, and I added 5 to that, so that means it's going to go left 5 units. Because remember, left and right does the opposite, right? Here, we subtracted 1, so that would mean it goes right 1 unit. Okay, so you do 17 and 18. And then we're finished. We'll talk about it more tomorrow.